Good morning, everyone. Today we're going to be starting our lesson on simplifying using prime factors, which is a continuation from learning about prime numbers and how to simplify. We're going to now put the two together. So as a reminder, prime numbers are numbers that are divisible by themselves and the number 1. So here's some common prime numbers. This should be familiar to you. The numbers 2, 3, 5, 7, and of course that list goes on. I want to show you an example today of how to simplify using prime factors. The numbers we're going to use is 36 over 48. So we're going to go back over here to these two numbers and we're going to be using our factor trees to determine the prime factors. So let's start with the number 36. And if you remember doing factor trees, we're always trying to find that prime number that divides into 36 or whichever number you're dividing into. So what is a prime number that will divide into 36? Let's use the number 3. 3 divides into 36 12 times. I'm going to go ahead and circle my prime numbers each time. The number 12 is not prime, so let's divide that out. We have 3 times 4 equals 12. Again, 3 is a prime number. Now we're at the number 4, which is not prime. And the two numbers that are factors are the numbers 2 and 2. So the prime factors of the number 36 are 3, 3, 2, and 2. So let's go on to 48. So again, 2 is always a good number to start with, so are 3 and 5, because those numbers are often divisible in. So let's go ahead and start with the number 2. 2 divides into 48. That would be 24 times. 2 is prime, we're going to circle that. So let's go to 24. 2 divides into 24 12 times. Let me circle that. And then we're down to 12 again, similar to the number on the left. We are going to do 3 times 4 equals 12. Again, I'm circling my primes each time. And this should be familiar to you because we have been working on factor trees. So in order to get the number 48, we could say 2 times 2 times 3 times 2 times 2. So once I have these prime factors of the number, I am going to now move over to my fraction. So the prime factors of the number 36, again, let's look back over here. We have 3 times 3 times 2 times 2. And I'm going to go ahead and keep it in that same order. 3 times 3 times 2 times 2. So 3 times 3 is 9, times 2 is 18, times 2 is 36. Okay, let's do the same with the number 48. I have a bunch of 2's. I'm looking for 3 so I could keep it even. So I have 3 times 2 times 2 times 2 times 2. So we'll start with the 3 here. And again, how many 2's do we have? 1, 2, 3, 4. So 3 times 2 times 2 times 2 times 2. Good. So when we multiply that out, 3 times 2 is 6, times 2 is 12, times 2 is 24, times 2 is 48. So both of these are broken down into their prime factors. So instead of simplifying like we've been doing, maybe by starting divisible by 2, by 3, what have you, we're going to look for pairs that match to form what a giant 1 that we've been working with too. So any number over itself equals 1. So we're going to look for matches. So I have 3 and 3 as a match. That forms a giant 1. 3, nope, that doesn't work. Oh, here's 1. 2 and 2, they match. That forms a giant 1. And here's another one. Perfect. 2 and 2, they match. They form a giant 1. So remember that any number that multiplies by the number 1 never changes its value. So I have 3 1's here. I could kind of ignore them or just remember the number times 1 will remain the same. So let's look across the top. The only number I have left is this 3 here. So I'm going to continue on down here. So on top I have 3 times 1, or 1 times 3 times 1 times 1 will equal the number 3. And across in my denominator, I have 1 times 1 times 1, which again is still the number 1. And then I have 2 times 2. 2 times 2 is 4. That is my simplified fraction. So if you could please review this a few times before you get to class tomorrow, because we are going to be working on simplifying fractions using prime factors. Okay, have a good evening. Bye.